Welcome to Naradar Academy. In this video, we are going to discuss about finding the solution of differential equations which are reducible to linear homogeneous equation. So consider this equation: a plus bx the whole square d square y by dx square plus a plus bx p1 into dy by dx plus p2 y equal to capital X, where this p1 p2 are constants and capital X is a function of x. Now we are going to modify this equation as a linear homogeneous equation by this substitution. Let u equal to a plus bx. Then by after few steps we will be getting a plus bx into dy by dx. That is, this term is there, no? This will reduce to bu into dy by du, and this term a plus bx the whole square into d square y by dx square will reduce to b square u square into d square y by du square. Okay, then this equation reduces to a linear homogeneous equation which can be solved by the procedure. Okay, so let's see some examples for this type of problem. Solve 5 plus 2x the whole square d square y by dx square minus 6 into 5 plus 2x dy by dx plus 8y is equal to 6x. So what is the substitution here? So before going to the substitution, let us identify this equation. See, this is a second order equation because this is the highest order derivative and the coefficients are not constants. They are x terms. Okay, and this d square y by dx square is having 5 plus 2x the whole square as its coefficient, and dy by dx coefficient is 5 plus 2x, and this y has a constant coefficient. And on the right hand side we have function of x. So for solving this type of equation, we have to let the substitution as u equal to 5 plus 2x. So this 5 constant is called a and this coefficient of x2 is called b. Okay, in that case this 5 plus 2x into dy by dx will be equal to 2u into dy by du. What is this 2u? That means bu. Here b is 2, no? So 2u into dy by du, and the second derivative 5 plus 2x the whole square into d square y by dx square will become b square u square. What is b here? 2. So b square u square into d square y by du square. So let us substitute all these values in the given differential equation. So it will be reducing to 4u square d square y by du square minus 6 into, already there is a constant 6 here, no? So that's 6 into 2u into dy by du plus there is no change in this y. So 8y is equal to 6 into, instead of x, let us substitute this value. See, u equal to 5 plus 2x, no? So x equal to u minus 5 by 2. Okay, so after simplification we will be getting 4u square d square y by du square minus 12u dy by du plus 8y equal to 3 into u minus 5. Now look at this equation. This is again a second order equation. Okay, second order equation, and this is linear because all the that is y terms and its derivatives are of degree 1. So second order equation and linear and homogeneous also. Here homogeneity means second order derivative has u square as the coefficient, first order derivative has u as the coefficient, and y has only a constant coefficient. Okay, this is a second order linear homogeneous ordinary differential equation with variable coefficient. Why it's variable coefficient? Because u terms are here, no? They are not constant. So this is a second order linear homogeneous equation with variable coefficients. So we are going to solve this differential equation by using this method. This video already I have uploaded. I have given the link in the description. If you want, you go through that video. Okay, now we'll see how to solve this type of equations. Again, for solving this equation, we are going to make one more substitution. Let z equal to log u. That implies u equal to e power z. In that case, the first derivative u dy by du will become capital dy, and second derivative u square d square y by du square will become d into d minus 1 into y. Substitute all these values in the differential equation. We will get it like 4u square. Sorry, this is the differential equation we have obtained in the previous step, no? Here in this one, I am going to substitute all these values. So what will you get? 4 into, instead of u square d square y by du square, d minus 1y minus 12 into, this is dy plus 8y equal to 3 into u. What is u? E power z. E power z minus 5. So let us simplify this expression. 4d square minus 4d minus 12d plus 8 into y equal to 3 e power z minus 15. That is 4d square minus 16d plus 8 into y equal to 3 e power z minus 5. Now look at this equation. This is a second order equation. And it is linear and it all has constant coefficients. Okay, all the coefficients are constant. So this is the equation in y and z. That is, z is the independent variable and y is the dependent variable. So by using the method of solving second order linear differential equations, we are going to solve this. Okay, for solving this, we have to find the solution in two steps. One is complementary function, the other is particular integral. For finding the complementary function, we are going to take only the left hand side. 4d square minus 16d plus 8 equal to 0. So replace d by m. So 4m square minus 16m plus 8 equal to 0. So throughout we can cancel one 4. So it's m square minus 4m plus 2 equal to 0. Now we cannot factorize this as it is. So let me make use of this formula. If ax square plus bx plus c equal to 0 is the quadratic equation, then x values are given by minus b plus or minus root of b square minus 4ac by 2a. I am going to make use of this for finding the values of m. So m equal to, here a is 1, b is minus 4 and c is 2. So substitute here. It will be 4 plus or minus root of 4 square is 16 minus 4 into 1 into 2 by 2 into 1. So m equal to 4 plus or minus root of 16 minus 8 by 2. It's equal to 4 plus or minus square root of 8 by 2. Square root of 8 is 2 root 2. Okay, only this is a positive number. So we will be getting 2 root 2 only by 2. So throughout we can cancel 1 2. So finally we will be getting m equal to 2 plus or minus root 2. So one root is 2 plus root 2. The other root is what? 2 minus root 2. So here we are getting real numbers only. They are not complex conjugates. They are real numbers only. But we are having irrational roots. For irrational roots also, you will be having only in pairs. If one root is 2 plus root 2, the other root will be 2 minus root 2. Root 2 is an irrational number, no? So this entire thing will be irrational number. So the roots are real and distinct. When you have real and distinct roots, the complementary function is a e power m1z plus b e power m2z. Remember, the equation is having z as the independent variable and y as the dependent variable. So you have to write the complementary function in terms of z only. A e power, the first root is 2 plus root 2 z plus b e power 2 minus root 2 z. Okay. Next we are going to find the particular integral. So particular integral equal to 1 by 4d square minus 16d plus 8 into 3 e power z minus 15. We are having two terms in the right hand side. So let us separate them as different terms. The first one is this denominator into 3 e power z minus the second one is the denominator into the number 15 alone is there, no? So that we can write it as 15 e power 0 z. E power 0 is 1 only, no? So there will be no change in the value. Because then only we can easily find the particular integral. So for making the calculation easier, I am making it as 15 e power 0 z. Okay. When you have right hand side as an e power alpha z, you have to replace d by alpha. Okay, that is the coefficient of z here. So here the coefficient of z is 1. 3 e power z only, no? So replace in this part, replace d by 1. So 4 into 1 minus 16 into 1 plus 8, 3 e power z. So this part is over. Next here is the coefficient of z is 0. So here in this part replace d by 0. So 4 into 0 minus 16 into 0 plus 8 into 15. Okay, hereafter no need to carry over the t power 0 z. That here for making only the substitution I have taken like that. Now this is over. So simplify this expression. So we'll be getting particular integral is equal to minus 3 by 4 e power z minus 15 by 8. That's all. So we find the complementary function and particular integral. So the general solution is complementary function plus particular integral. So already we found the complementary function. So write them together. So this is the solution. But this solution is in terms of z. But original problem is in terms of x only, no? So we have to substitute z equal to log u. But again u is not the required variable. U is equal to what? 5 plus 2x. So z equal to log u is equal to log of 5 plus 2x. Do this replacement. Wherever you find z, replace it with log of 5 plus 2x. So y equal to a e power 2 plus root 2 into log of 5 plus 2x plus b e power 2 minus root 2 into log of 5 5 plus 2x minus 3 by 4 e power log of 5 plus 2x minus 15 by 8. Okay. Now this is equal to, see, for I'm going to use some of the properties of logarithmic function. A log x, that is a into log x, can be written as log of x power a, and exponential of logarithm of x is equal to x, that is e power log x is equal to x. So I'm going to make use of these two properties here. So here we have 2 plus root 2 in the front, no, that will become 5 plus 2x the whole power 2 plus root 2 plus b. Similarly here also e b exponential of logarithm of 5 plus 2x power 2 minus root 2 minus 3 by 4. This is exponential of logarithm. Exponential of logarithm is equal to the function value only. 5 plus 2x minus 15 by 8. Okay. Now here again, here also we have e power log, e power log. So we will be getting only this value. So a 5 plus 2x power 2 plus root 2 plus b 5 plus 2x the whole power 2 minus root 2 minus this value is 15 by 4. Okay, minus 3 by 2x minus 15 by 8. So by simplification we will be getting the final answer as a 5 plus 2x power 2 plus root 2 plus b 5 plus 2x power 2 minus root 2 minus 3 by 2x minus 45 by 8. That's all. This is the solution of the given problem. Okay, that's all. Thank you.